Hi, we're the Gravity Fed Water team. Thank you for coming to our presentation today. I'm Ella Sobek, the Student Project Manager. Also on our team is Jordan Higley, a Senior Civil Engineering major, Sarah Aldrich, a Junior Environmental Engineering major, and Joe Grant, a Junior Civil Engineering major. Our project manager is Dr. Sorens, and we partner with the Mennonite Central Committee to design a gravity-fed water system for a village in Sipacapa, Guatemala. The purpose of our project is to design a water system fueled by gravity to deliver safe and clean water from a mountainous source to the village of Sipacapa, Guatemala. Currently, the people in this village, which is about 150 people, don't have direct access to safe and clean water in their village, and they have to travel to the river and get it and drive it back to their village. So there are some key constraints in the system that we're going to go over quickly. So the first is that the source is uphill from the village and about 3 kilometers away. So the solution to this is to use a gravity-fed water system. It's the most cost-effective way to deliver the water from the source to the village. Another key constraint is that there are a lot of unknowns about the source and the source flow and the general environment. And so we're working to communicate really clearly with our partners and local organizations to help get more information. We're going to do a brief overview of the system before we move on and look at more specific elements of the system. So the system is designed to serve about 150 people living in Sipacapa, Guatemala. Their water source is 3 groundwater springs, and the water from these 3 springs will be combined and then sent through a pipe network to the village, which is about 3 kilometers from the source. Once it gets to the village, the water will be stored in storage tanks for the people to be able to use. Some preliminary water treatment has been performed already on water samples from those sources, but once the team is on site, more extensive water testing will be performed, and then, if necessary, the water will be treated. The team plans to travel to Guatemala sometime in the future to install the intake and the first section of pipe.
So now I will discuss our intake system design. The plan is to have 3 smaller intake structures placed on groundwater seeps, and these smaller intake structures will feed into one larger intake structure. The flow rate of this larger intake structure will be measured to be approximately 7 gallons per minute. All of these intake structures will be made out of concrete, and the cost of all of them will be approximately $1,000. And then as far as the cost for the entire gravity-fed water system goes, it will be a little over $12,300. So these gravity-fed water systems are very common in Guatemala. There are workers that have built these intake structures. So the plan is to get the help of these workers while we are in Guatemala building the system. So now I will discuss the water testing and treatment. So far we have tested the pH, alkalinity, turbidity, conductivity, and the hardness. All of these values are within normal range, which is great. And we plan on using an Aquagenics water testing kit to test for indicator coliforms on site. So this is not able to be tested for until after the intake structure is built. This is because in order to get an accurate reading of how much bacteria there is in the water, we are not able to test until that intake structure is built. And then depending on those results, it is possible that the water may need to be chlorinated.
An important part of our system is the pipe network, which will deliver water from the intake structure at the source to the storage tanks in the village. And it also has a separate branch off of it to like a separate group of houses. So from the source to the last point that we were given is 1.6 miles with an elevation drop of over 1,000 feet. So then the total length of pipe that we would need is 1.8 miles. So we performed some pressure calculations and head loss calculations, and from this we determined that the pipe we're likely going to use in the system is 1¼ inch PVC pipe.
Hey everyone, this is Jordan. I'm just going to talk real quick about what we plan to do for water storage in our Guatemala system. So obviously we're going to be using tanks, and the first thing to determine is the material that they're going to be made out of. So our choices were really between concrete and plastic. The plastic tanks are pretty cost effective, but they're not very strong in the long run. And while the concrete ones do cost a lot up front, they do give you much strength for many years to come. So we ended up going with that as our material. The next thing to consider was how large the tanks needed to be. You consider a number of factors for that. There's how much water is coming from the source. There's how much is going to be used by the people. There's how much should be stored in the entire system as a whole. And that should be about a day throughout the whole system, pipes and tanks and everything. And finally, the pressure that's going to be building up in the pipes. So when you consider all that, you consider what we did in Vanuatu, you come to the tanks needed to be 1,000 gallons large. Now they can end up being smaller than that. That will provide enough storage, but right now that's the max that it should be at. Finally, I'm going to talk about the placement of the tanks. So we determined that 4 are necessary in the system, 1 right at the intake, 1 further down the line from the intake to help with the pressure buildup in that pipe, and 1 at the end of each of the lines running out to where the people are. We figure this is the best way in order to have water stored in a reasonable place for the people living around that. Finally, you'll see a couple pictures of the designs that we've been considering for the tanks. We've done a little bit of the initial design when it comes to building a tank from scratch, but as we've seen and as you'll see in these pictures, there's a number of concrete tanks already on site. And hopefully we'll either be able to take a similar design and use them, or use the ones that are already there in our system. So finally, I'm going to turn it over to Ella to talk about the conclusion of our video.
At the end of this presentation, we would like to acknowledge our partner, Jack and Sarah Lesniewski, who work with MCC in Guatemala. We'd also like to thank our project manager, Dr. Sorens, for all of his guidance and help. We would also like to thank all of our reviewers who came to our project reviews and gave us feedback on our work. And then finally, we'd like to thank our teammate, Joe Grant, who even though he didn't have to present in this presentation, helped us put together this video.